Hello everyone, my name is Raghavi Priya, Assistant Professor, Department of Computer Science and Engineering. So in this video, you are going to see about the lecture series of the subject 23 CST 201 Database Management System. So second year CSC 4th semester, Unit 4 Transaction. So the topic is Serializability. So let's recall of the previous lecture video topic. So mastering DBMS schedule summary. So here's the summary of the journey mastering DBMS schedules for correctness and performance. So the challenge what we have encountered is concurrent access chaos. So uncontrolled schedules leads to certain data anomalies. So it creates a lost updates problem. So the goal is serializability. So it ensures correctness. The goal is equivalent to a reference serial execution. So the solution, conflict serializability. We will draw a precedent graph. So it detects conflicts and acyclic graph. So the practical uses SQL isolation levels or testing. So SQL isolation levels balances performance. So manage real world concurrency and speed. So key takeaways: uncontrolled schedules cause data anomalies, conflict serializability restores order, and practical isolation levels balance performance. So recall summary: uncontrolled schedules cause data anomalies, conflict serializability, and restores order, and practical isolation level balances performance. So key concept is the journey begins with chaotic concurrent access and ends with orderly, correct, and efficient. So discussion, serializability in DBMS. So what is we are going to see about what is serializability in DBMS and why it is important. How does it relate to transaction consistency? So next one we are going to see about what are the main types of serializability, how are conflicts and view serializability different, when is each used, how do we test for serializability, what tools or methods are commonly used, what challenges might we face. So the solution is serializability, empathy, burden. So we have two transaction. So that is user A makes a withdraw. So the balance is 900. So next in T2 user B sees the old balance which is misleading her. So my balance isn't right. So wait, I saw 1000. So that will be an inconsistent result. So that is the user B gets a balance of wrong balance of rupees 1000. So old transaction, he sees the old transaction but the correct balance is 900. So this is a non-serializable execution. So in serializable execution, user A reads a balance of rupees 1000. So then writing the 900. So next user user B should wants to read the transaction amount, so makes it own valid decision. So again user A also getting the correct balance from the account and user B also getting the correct balance from the account. Then we will say it as a serializable execution. So here they are saying I made a save transaction details are clear. So this leads to the consistent result. So transaction gets complete. So what it achieves, what serializable execution achieves is user trust. So predictable action, then user clarity, transparent result, and user respect, consistent experience. So define serializability. notation, S tends to serial schedule. A schedule is said to be serializable if it produces the same result as a serial execution. For example, T1 tends to T2, T2 tends to T1. So both give correct and consistent results. So both should be same. So then only we call it as a serializable schedule. So consider this transaction as an example. So serializable schedule means there will be a correct and safe transaction execution. So types of serializability. So there are two types of serializability. So one is conflict serializability. So based on orders of conflicting operations, and view serializability based on how transaction view the database. So example, T1 read A, T2 write A will produces the same result. So that is conflicting operations. So conflict serializability should not equal to the view serializability. So prototype precedence graphs. A precedence graph represents the ordering of conflicting operations in transaction. So nodes represents transaction. So edges T1 tends to T2 represents conflict. So T1 depends on T2. So no cycle serializability. If it is cycle mean not serializable. So in this transaction cycle detected. So testing serializability, use precedence graph, check for cycles, apply graph traversals. Example, cycle exists, not serializability. So condition, result, graph, no cycle means serializable. If the precedent graph consists of a cycles mean not serializable. Cycle detection equal to testing method. Serializability example. So schedule, we have a schedule T1 in transaction 1 read A write B. So transaction in a transaction 2 write B read B. So this is a completely different statement. So this is a not serializable. Consider another schedule read A write B and write A. So next one T1 read B. So this is a serializable schedule. So advantages of serializability: ensures data consistency, provides correct results, avoids data anomalies, and maintain transaction isolation, safe concurrent execution. So concept: same result as serial execution. Types: conflict view. Tools used is precedence graph. So testing: cycle detection. No cycle means safe. If we have detected a cycle means there should be some problems. Data inconsistency. So this is the question quiz. So which graph shows a cycle? So the graph B, answer is graph B shows the cycle. So question 2, when is a schedule is serializable? So the schedule with no cycle is said to be a serializable. So right option is option A. So these are the few references. Thank you.